Ladies and gentlemen, welcome to this lecture. I'm Gautam Ram and I'm an assistant professor in the Delft University of Technology where I work on electric vehicle and battery technology. Several factors must be considered in the design of a battery pack. At the cell level, we need to consider the gravimetric energy and power densities, and at times also the volumetric energy density of the cell. The lifetime of the cells in terms of both time and number of cycles is critical and depends on the application. At the pack level, the key design considerations are the battery management and thermal management system, which effectively influences the cost, efficiency, and the safety of the battery pack. And finally, a modular design of the cell and pack enables repurposing of the pack for second life applications and recycling of the cell and pack for circularity. To understand this further, let us look at the design of a commercial electric vehicle battery pack. For this example, we use the Audi Q6 Quattro SUV as an example. We can see that the battery pack is placed at the bottom of the vehicle and the two electric motor drives to propel the vehicle are placed at the front and rear of the vehicle. To create the battery pack, 15 prismatic cells of nickel manganese cobalt oxide or NMC chemistry with ratio 8:1 are connected in series to create one battery module as shown. Each module has a dedicated cell module controller that measures and sends data such as a module temperature and individual cell voltages to a central battery management controller. Then 12 modules containing 180 cells in total are connected to create a 800 volt battery pack with an energy capacity of 100 kilowatt hour. For the thermal management of the battery pack, a cooling plate is integrated to the bottom of the battery pack. The plate has a U-flow architecture connected to a refrigerant loop that can both heat or cool the pack to ensure and relatively homogeneous heat exchange and temperature distributions across all the cells. To eventually integrate this into the electric vehicle, several layers are stacked together. Starting from the top, we have the top cover and the junction box and the battery management controller and a fire protection layer underneath. Then we have the 12 battery modules that are embedded in a structural frame. And below that, we have the cooling plate. A lower protection cover provides underbody protection as well as improves the thermal insulation of the battery from the environment. Such an insulation ensures that the battery can be cooled or heated more efficiently with limited losses to the environment. The layers are then stacked together to create an integrated battery pack that can then be placed at the bottom of the electric vehicle. The 800 volt battery pack can charge at a maximum power of 270 kilowatt from an 800 volt charger. An interesting feature of the Audi Q6 is the ability for the 800 volt battery pack to divide into two batteries of 400 volt rated voltage, which can then be charged in parallel when connected to a 400 volt charger. To enable this, both the 400 volts batteries need to be first equalized depending on the state of charge and then charged together in parallel.